Hello students, welcome to your lesson 6 instructional video. We're going to continue our working with subtracting rational numbers. Your learning target today is I can find the difference between two rational numbers. Here's your standard for the day. And then go ahead and get your lesson page set up. Get this paused to get everything glued in. Make sure you have your title, standard, learning target, and the date. And let's dig into our first slide. First thing we're going to talk about is this idea of a difference versus distance. So when we are talking about a difference of two numbers, a difference is the solution to a subtraction problem, and it can have a positive or a negative value. So we might say that a sum is the solution to an addition problem. The difference is the solution to a subtraction problem. An example here, what is the difference between negative 100 and negative 33? Well, that would be negative 100 minus negative 33, which comes out to negative 67. You could use a number line to solve that. You can do this by hand, or you're welcome to use your calculators as well. So we're also talking about what is this idea of distance between two numbers. When we're asking you the distance between two numbers, we are specifically talking about the magnitude, the size, or the absolute value of space between the two numbers. And distance is always, always, always going to be a positive value. It's always positive. So an example of that, using those same two values, the distance between negative 100 and negative 33 is negative 100 minus negative 33, but the absolute value of that. So the absolute value of 67, which is positive 67. So how can we work with these expressions when we're talking about altitude? So here we have this amazing climber and mountaineer, Maisa Lima. And Maisa Lima is climbing in the Grand Canyon and needs to record her elevation changes in order to keep track of her locations. We are being asked to write and solve an expression that represents the difference between the final elevation and the beginning elevation. So it's very important when we are reading through the instructions or reading through what a problem is asking us to do that we pay close attention to, are we looking for the difference or the distance? Are we looking for change? What is the question asking us for? And it's helpful to highlight or underline the specific clues that are telling you what a question wants you to do. And also, when we're talking about subtraction, it is really important to pay attention to what comes first in a sentence. If we're being asked the difference between final elevation and beginning elevation, that means that we need to make sure that that final elevation is first in our number sense. So example, if Maisa's beginning elevation is negative 100 feet and her final elevation is negative 200 feet, but we are specifically looking for the distance between the final and the beginning, that final is going to come first. So we're going to say negative 250 minus that beginning, minus negative 100. And again, you can do this in your head, or you can grab a calculator, or you can make yourself a number line. But that comes out to a difference of negative 150 feet. So what distance did she cover? Well, this distance is going to be a little bit different. This distance means that she went from the final of 250 feet minus her starting spot of 100 feet, negative 100 feet, I'm sorry. And to find the distance, we want that absolute value. So we want the absolute value or the magnitude of the difference. 150 feet, which just equals a positive 150 feet. When asking does order matter when we are working with subtraction problems, the short and boring answer is that absolutely yes. In subtraction, the order of your terms matter. Switch your orders and you get different values. However, when we do change the order in a subtraction problem, we see some really interesting patterns. So I wanted to show you an example. Let's start with -3 minus -7. We'll do this one in green. So I'm just going to plot this on the number line. Start with moving to the left, -3 units. There's my -3. And then since I am subtracting 7 negatives, that is actually going to send me off to the right. They're subtracting 1, removing 2, removing 3, 4, 5, 6, 7. So we land here at positive 4. So -3 minus -7 is a positive 4. Now let's see what happens when we switch that order up, and instead we do -7 minus -3. So same process, always starting at 0. That -7 is going to move me 7 units to the left. There's -7, and this time I'm subtracting 3 negatives instead of 7 negatives. So it means I'm going to start there at -7 and move 1, 2, 3 units to the right. And I'm going to land here at -4. So -7 minus -3 is -4. So right off the bat, you might notice we switched that order and we came up with -4 and 4, which are the additive inverse of one another. Additive inverse, let's do the the additive inverse of 4 is -4. And also, when we switch those values, we can notice that the magnitude of 4, so the space between 0 and 4 is 4, and the magnitude also of -4 is 4. So when we change the order, not only do we come up with solutions that are additive inverse or opposites, but we also come up with solutions that have the same magnitude. So now it's time for you to try some. Why don't you write and solve a number sentence to represent the difference between -8 and -11. Go ahead and pause it. Okay, welcome back. So that could look like -8. Remember, if that's what comes first, that's the first thing you put down, and minus -11. Again, we're looking for the difference here, not the distance. Maybe you made a number line, maybe you did this by hand, maybe you popped it in your calculator. But I got an answer of +3. Now try this one. Write and solve a number sentence to represent the difference between -11 and -8. Go ahead and pause it. So what I have, since -11 comes first this time, it's -11 minus -8. And I come up with -3. Your next steps, go ahead and find those 1.6.3 practice problems in the unit materials bin up at the front and get going. Thank you.